Perhaps one of the most fascinating inquiries we've all pondered when we were kids is whether we can go into the future or go back in time utilizing some kind of time machine. This question remains captivating even in our grown-up lives. Luckily for us, science has progressed to the point where we can respond to this deep-rooted question. We can undoubtedly go forward in time, and we've known the most effective method to do that since around 1905. Einstein's special theory of relativity lays out the entire recipe of how you can move into the future. All you need to do is go into a lower gravity field compared to others or travel exceptionally fast, and your clock will tick slower than that of everyone else that you've left behind. Then, when you return, you'll be younger than your twin, for instance, if you had left your twin back on Earth. In that sense, you are going into the future, and that's not difficult to do. We've known how to do that. Traveling backward is the issue we think we can solve. I have some colleagues who've made computations that state that, depending on a trajectory you take around a black hole, you can emerge and end up in the past from when you started. But that takes a phenomenal arrangement to get going. At the present time, there's no issue with traveling into the future. We've known the answer, and it is totally conceivable to travel forward in time. In reality, we have obvious proof to show that. So before we delve into the complexities of going back in time, we should first see why researchers are so sure we can go into what's in store. The faster you move, the slower time ticks for you, as others perceive it compared to the observer. You know nothing's going on, your clock still ticks as far as you've still got your heartbeat. This is all not a physiological thing, it is a real property of the fabric of existence. Under those circumstances, if I observe you fly by, the quicker you go, the slower time ticks for you. So, besides the fact that speed does this, the strength of a gravitational field will significantly affect you. At first, when you're thinking it's for no obvious reason, you're moving, it's entirely more profound than that. The GPS satellites orbit higher than our space station. The geosynchronous satellites are like a center circle that is far enough away from Earth's wellspring of gravity for them to have a quantifiably different spacetime condition. So, their timekeepers tick quicker than our clocks on the planet's surface because they're farther away. Their time ticks quicker compared to us. However, we get exact timings from geosynchronous satellites. How does this work? We precorrect the time signal from the GPS satellites to make up for Einstein's general theory of relativity, so that when the time contacts us, it's been properly corrected and is meaningful to us and our spacetime continuum, not the one that is in the center Earth orbit. Once you work out that, then you do, and you say, oh my golly, the equation works. Einstein was correct, it is valid. In physics and relativity, time dilation is the difference in elapsed time as measured by two clocks, either due to a relative speed between them or to a difference in gravitational potential between their locations. For instance, close to the area of a black hole, to a far-off observer, clocks close to a black hole would seem to tick more slowly than those farther away from the black hole because of this effect known as gravitational time dilation. An object falling into a black hole seems to slow as it approaches the event horizon, taking an infinite amount of time to reach it. As we said, apart from the difference in gravitational potential, there is another method for going into the future, traveling through space at relativistic speeds. As you approach the speed of light, something truly peculiar begins to happen. Let's keep going faster, 90% the speed of light, 99% the speed of light. Time is ticking more slowly and increasingly slowly for you. You will watch the entire future history of the universe unfurl in front of your eyes as mere parts of a second go by for you. As you go 99, 99.9, 99.99 the speed of light, there's a formula for this. Obviously, special and general relativity suggest that reasonable calculations with spacetime or explicit sorts of movement in space could permit time travel, not just into the future but also into the past. Anyway, time travel into the past is theoretically possible in certain general relativity spacetime calculations, but only while traveling faster than the speed of light is allowed. The issue with traveling back into the past is the other side of the coin of the spacetime continuum, which is that space travel back is not enough, you also need something to drive you in space too. So, it's a spacetime machine in addition to a time machine. Earth is a moving target, and I just want to make that clear. By the way, if you travel back into the past, you may still land on Earth. But how was Earth turned? You could end up in Siberia in the sea, probably because the majority of Earth's longitude is traversed by the ocean. So, it's reality in time travel as to these spacetime coordinates. Now, we call these your direction in space and your direction in time. We call that your world line. Another issue with traveling back into the past using a time machine or a space-time machine is the alleged grandfather paradox. What is it, exactly? You can't travel back into the past and prevent your parents from meeting each other because then you could never have been born to have traveled back into the past to have prevented your parents from meeting each other. This is the crucial catch, 22 of time travel. So, if there were a rulebook, that would be the number one rule. Maybe the most ideal way to travel back into the past is to use wormholes. The theory of general relativity does suggest a scientific reason for the possibility of backward time travel in certain strange situations. So, going through a stable wormhole could theoretically allow you to travel back into the past. We have the kind of fabric of the space-time continuum. It's not only that space is out there, space is right there, unpredictably arranged with time. And how do you know this? Space and time are forever conjoined. This fabric can be distorted so that you can change the distance, the space-time distance, between two areas. One way to envision that is to imagine our universe is all on a flat piece of paper. You're on one edge of the paper, and I want to get to the other edge. I require an enormous amount of time, whatever that requires, it's light years distant. So, I need many years traveling at the speed of light. But if I take the space and bend it back on itself, now your location is very close to me. If I could somehow punch through the fabric of reality and reach your location, something that would otherwise be longer, a shorter distance. Consequently, rising above the speed of light to do so means you're not limited by the speed of light. The diameter of our universe is 100,000 light years. You can't traverse it unless you figure out a way to bend existence. So, in that bend, fundamentally on paper, you can have a hole that you go through and just come out the other side, and you're in somewhere else. And if you did it right, you can appear at some other point. That is the most traditional notion of a wormhole. One more approach for backward time travel involves a dense rotating cylinder, commonly referred to as a Tipler cylinder. This theoretical cylinder is vastly lengthy and twists quickly enough about its long axis, and a spaceship flowing around the cylinder or following a twisting path could go back in time or forward, depending upon the direction of the twisting. However, the density and speed required are so incredible that standard matter areas are not strong enough to develop it. Incidentally, if you manage to travel somewhere faster than light, you have the ability to move backward in time. We've got that one laid out, we just don't have any easy way to travel faster than light. But one way that has been praised in sci-fi, and you can get it out written down, is a wormhole. A wormhole, I'm here, and I need to move past there, and I want to get there quickly. You can go through a wormhole that changes the effective distance between where you are and where you're going. Then, you kind of check out when you arrive, and you find, oh my golly, I've traveled 100,000 light years in a matter of seconds. When that happens, you have the ability to move backward in time relative to when you left. Now, you don't get to visit yourself, you're in a kind of a different space-time trajectory, so you can't shake hands with yourself before you left. Incidentally, there's a huge paradox that many people, including the late Stephen Hawking, worried about, whether this conundrum would prevent backward time travel altogether. Because if you travel back into the past and prevent your parents from meeting each other, then they could never have brought forth you to return to keep them from meeting each other. Thank you for watching. Did you like this video? Then show your support by subscribing, ringing the bell, and enabling notifications to never miss a video.